Okay, so we've proven that f of f inverse of x equals x. We now need to do the second half of that. So f inverse of f of x. So f inverse of 2x plus 3, we want to see, does this equal x? I'm taking the 2x plus 3 and plugging it into the inverse function. 1/2 of 2x plus 3 minus 3. And again, I've just left these parentheses to show where the input went, but they're not doing anything. I'm not distributing across them. So I have 1/2 times 2x. Now 3 minus 3, they cancel. So I have 1/2 times 2x. Well, 1/2 times 2x is just x. So x does equal x. Excellent. We've now proven that f inverse and f are inverses of each other. Okay, we'll do one more here. And this one we're just simply looking to see, again, is f and f inverse really inverses of each other? We want to prove it algebraically. So to prove this, I have to say, does f of f inverse of x equal x? And does f inverse of f of x equal x? So we're trying to check out both of these things. And yes, there's fractions, but it won't be too bad, I promise. Okay, so f inverse of x says I'm going to take that x, divide 3 by x, and then subtract 5. Now I'm going to take this whole thing and plug it into f of x. So when I plug that in, I'm going to have 3 over x minus 5. So that's my input right there, plus a 5. Okay, it looks bad, but notice right here, -5, +5. Let's go ahead and just cancel those out. So now I have 3 over x. There we go. So the way we deal with when we've got a whole number divided by a fraction, I've got to take that fraction and take the reciprocal. So the reciprocal simply means I'm going to turn it upside down. So the numerator went up here, the denominator came here. Or sorry, the denominator became the numerator became the denominator. I cross this guy out. Now I multiply. 3 times x gives me 3x over 3. So that's just x. So f of f inverse of x is x. So that's good. We have checked that. Now we need to do it the opposite way. So f inverse of f of x. So f of x says take the x, or your input, divide 3 by your input plus 5. So I now need to take all of this and input it into my f inverse function. So 3 divided by 3 over x plus 5. Actually, I don't need those parentheses there, but it doesn't hurt. Okay, so again, I've got a whole number divided by a fraction. So I've got to take this fraction and take the reciprocal of it to simplify this. So the denominator is going to become the numerator, so x plus 5. The numerator becomes the new denominator, and I cross that out. And now we go ahead and let's write this. We've got 3 times x plus 5 in the numerator over 3 minus 5. So rather than distribute here, let's go ahead and cancel the 3's. Since they're both multiplied, I can cancel them. I'm left with x plus 5 minus 5. Well, plus 5 minus 5 is 0, so x does equal x. Excellent. We are good there. Okay, now we have this theorem that says that the graph of function f and the graph of its inverse are symmetrical in respect to the line y equals x. So let's see what this looks like. Turn over our paper. And let's take a look at these points. Let's shrink this down so you can actually see. Okay, so if I've got this point, -2, -1, -2, -1, the inverse of that, the x's and y's are switched. If the inverse switches our x and y's, this y value is going to become the x value in the inverse. The x value is the y value in the inverse. So the symmetrical inverse here is going to be at -1, -2. I'm going to do the same thing with the next point. Negative 1, 0. In the inverse, that's going to be at 0, negative 1. So 0, negative 1. And these were connected, so they're connected in the inverse. And the final point on the original function was at 2, 1. This would, in the inverse, be at 1, 2. So 1, 2, approximately right there. And let's connect those. Now notice what this one, the theorem on the previous page said, is that our inverse and the function and its inverse are symmetrical across the line y equals x. So this is y equals x, just that diagonal line. And notice that if you were to look at it this way, the function looks like it's been reflected across that line. And that's what inverses do, is they reflect across y equals x. Okay, so how do we find the inverse of function f? I'm going to put a step 0 in here and say replace f of x with y. So the first thing we're going to do is take out our f of x and replace it with y. So what we're doing right now is, how do you find your inverse? How do you create one? And to find the inverse, we're going to follow these steps. First thing, we take out the f of x and put a y there. Step 1, the official step 1, is to switch our x and y's. So if I want to switch my x and y's, wherever there was a y, I'm going to put an x. Wherever there was an x, I'm going to be putting a y. And now I have to solve this, or manipulate it, to solve for y. So I want y by itself. So first thing I'm going to do is subtract 3 from both sides. So I have x minus 3 equals 2y. I now need to divide both sides by 2 so that I can get y by itself. So I've got y is equal to x minus 3 divided by 2. And we can write it like this. This is the same as x over 2 minus 3 over 2. Both of these are equivalent, both are equally good. And to designate that this is the inverse, or what I think is the inverse, I'm going to replace the y with my inverse notation. So f inverse of x is equal to x minus 3 over 2. So there is what I think the inverse is. To prove that it is the inverse, I'm going to show that f composed with f inverse of x is equal to x. So f of f inverse of x, and I'm putting a question mark there because we don't know that yet. We want to prove this. So f of f inverse, here's my inverse, so x minus 3 over 2. We want to see what this equals. So x minus 3 over 2 is the input now for the original function. The original function says 2 times what your input is plus 3. Well, here I'm multiplying the numerator by 2, but I'm also then dividing by 2. So the 2's cancel with each other. So I have x minus 3 plus 3. The 3's cancel, so I have x equals x. I have now proven that this is the inverse of function f. Okay, so we've got 2 more examples, and I'm actually going to jump to example C first. It takes a little less room. Okay, so f of x equals x squared if x is greater than or equal to 0. And we had to add this to make this a 1-to-1 function. So we only want half of our parabola. So first thing I'm going to do is replace f of x with y. So y equals x squared. Now I want to find the inverse, so I've got to switch my x's and y's. So I get x equals y squared. I'm trying to solve for y, so I've got to take the square root of each side. And when I take the square root of a squared, I just get y. So y equals the square root of x. And I can replace that with my inverse function notation. Okay, and the final step now, let's show that this really is the same thing. So I want to show that f of f inverse of x equals x. Okay, so f of the square root of x, now plug that into the original function, so the square root of x squared, square root and square cancel each other, so I get x equals x. we have shown that those are inverses.